So thank you to come to this presentation about Istio. I will share with you how wonderful can be Istio for you as a developer or as an operator in both sides. So first things first, our world is changing. I came from a world where we can deploy an application in production with everything inside the same fat jar. The application, the file server, even the SQL database was embedded inside the application. So it was long ago, and now thanks to Docker, we are able to split our monolith and to communicate over HTTP. But we are not Netflix or even Amazon with so impressive and whoa, 20 slides. Amazon and Netflix with so many microservices in production. We have many, and we want to manage them in production. And to do that, we are usually using currently Kubernetes, a service orchestrator to help us to do that kind of action with multiple services in production. But still, Kubernetes doesn't solve everything. It's about running system, running workloads, but not everything can be done with Kubernetes. And this is where Istio came. So for me, I'm Kevin, Google developer expert on Google Cloud and Kotlin, so both on operation and development, and also part of the GitLab Heroes program. And I'm working at Gradle currently. Gradle is very famous for this build tool, but we are also working on other way to make developer happier. It's our credo at Gradle. And one thing is developer productivity engineering. We are very invested in that kind of thing to provide the best experience at development level for every developer. And we are developing Gradle Enterprise, a really amazing tool to provide you amazing and lots of information about your build system. So from build, test, and everything around dependencies and so on. It's very complete solution, and it's really amazing. And I've done that this morning to be able to for locally run something and rely on something else for the test distribution part. A really amazing feature, by the way. So going back to the Istio subject. So it's about container, it's about Docker. I talked about Kubernetes, the cloud, obviously, and Istio. First, in this presentation, I want to warn you about something. If everything is a buzzword in this kind of introduction, and I want to share with you, if you don't need Istio, if you don't need Kubernetes, and you just want to run something, for example, in App Engine or in the VM, just do that. If you don't need every wonderful stuff I will present you, just stick with the standard way of doing, because it's simpler than bringing everything I will introduce you, and at the end it's harder to manage than just your simple application. So Istio, we'll talk about its history. Istio is a open source project from Lyft, IBM, and Google. And I said it's an open source project, and it's open source from scratch. And when I say from scratch, it's from the 100, sorry. And at this moment, nothing was working, and some people start to try Istio for development. But I also knew some people doing Istio using Istio in production with 0.7 or 0.8. It was a mess at this moment, but still, it was for something in production. And then the 1.0 and the 1.1 bring some very fundamental piece in Istio, and the project is now very stable. Before the 1.0, some breaking change happened, but here and now it's very stable and very powerful. There is not a lot of amazing feature at each release. It's mainly a better way to manage and to operate Istio than adding a killer feature every 3 or 4 months. And Istio is very young, almost 5 years now. But if we think about it twice, it's 5 years on the Kubernetes domain, which is 7 years old. At the end, it's not so young in this context. So what is the main goal of Istio? In our context, Istio is here to help you to build your microservices with high level of quality and being reliable at production grade. And it's also technology agnostic, a really important thing for me, because if I want to develop something, I can use my favorite language, but if I need to develop something for business analytics or for big data, whatever, I don't want to bring my favorite language. I have a specific need and I need some specific tool. So I don't need to stick with everything in the slides. I need to choose and to care about the solution. If I just need to do some HTTP call, I can bring bash and curl, and it's enough. I don't need to start a JVM and don't need to bring this kind of library, which is very good, by the way. The Netflix stack and the security and Spring Cloud one is very wonderful. But if you are not in the JVM environment, it's not the way to do with Istio. And Istio is also infrastructure agnostic. You can deploy it with Kubernetes, Consul, Mesos, Nomad, and even with VMs. We'll see it after. And with Istio, you are able to observe things, connect, control, and securize everything with ease. For me, Istio is the first tool which is distributed by nature. So this one is able to help you during development of your distributed software. Very, very helpful. So we will take a look at the Istio architecture now. So before digging into Istio, we'll take a look at where is Istio in this map. So first, on the bottom here, we have the deployment platform, which is Kubernetes. Kubernetes, its role, it's to launch things, pods, containers, and if you deploy manifest with 3 replicas, it will try to fill this gap with 3 replicas in production. So, okay. Your application here is just a black box with listening on the network over HTTP, for example, listening data, receiving some, storing its state inside the database, and answering back in the wire to the previous caller. Very simple case. And Istio is in the middle here. It's a service mesh. Be careful, it's another buzzword here. Istio is almost the Kubernetes way of doing the network inside Kubernetes. It's the same thing. Kubernetes, it's about deployment, and Istio, it's about network. And because of that, Istio will be able to get all the control over the network to provide you wonderful features. But first time I seen that, I was a bit confused, because in Kubernetes, I have something to do some network stuff, and I can do that also in Istio. And I have some reliability libraries in my application. I also have that in Istio. So you need to take care of which part of this infrastructure or from your hub is responsible for this kind of thing. So be careful. And in this presentation, most of them are Istio related and not Kubernetes or your hub. This is the way to do with Istio. So in Istio, you have two pieces of software, the data plane and the control plane. The data plane is just a proxy deployed along your favorite application. Here, for example, a Micronaut Kotlin application. And when your application is calling the outside world, another pod or outside the cluster, in fact, it will call the proxy, because AP table has been rewritten by the some init container at the beginning. And then the communication will be initiated by the proxy to another application, and here with the Python Flask application. And the communication inside your namespace or inside even your cluster is done through proxy to proxy. So thanks to that, you are able to get every information about the network, number of requests, time to first byte, size of each request, and whatever data and metadata about the network. And the proxy is able to send all these data, send them to your specific dashboard monitoring system, Datadog, APG, Cloud Monitoring, whatever solution you are using in production. And the other part is Istio control plane. It's called Istio-D. And in fact, there's multiple parts in Istio-D. And my favorite one and the most important one is the pilot. The pilot is responsible to gather every network information from Kubernetes. So do you deploy a new service? Yeah, what is the IP of this service, the name, and what is the route to go from this service A to the service B? So it's the responsibility of the pilot to get all this information. it's like a database, and it will spread this information to every proxy. So it's a distributed database with the main part, which is the pilot, and proxies, which are just some kind of replica in this context. So if we take a look at this application, your application in production, we have the service A and service B without Istio. And with Istio, we add two proxies and something in a specific namespace. Very simple. And thanks to that, we'll be able to do these four pillars provided by Istio: observability, connection, control, and security. We'll dig inside every aspect of that. So first, it's observability. Spoiler alert, it's the main reason why people choose Istio. Even if all the other things are wonderful, at the end, doing some observability stuff inside Kubernetes is really hard. So just with Istio, you are able to monitor and observe things inside your cluster. There is a lot of open source tools involved here, and the best way to demonstrate this is by an example. So here you see in my slide some Kotlin code. It's very reactor and reactive programming Kotlin here. And you see between those two methods, there is only one difference: vpwiz in one case and flatmap in the other one. The solution is at the end parallel or sequential. One is done in parallel, the other one is sequential. And both are working well. So if you deliver that in production, everything should be okay, because it's calling two things not at the same time, but just in seconds. So if you deploy it, at the end, you will see that this overlapping thing here, there is no overlap. And if you deploy the thing on one, you see some overlap. And it's important to see that, because if you are not able to observe this kind of thing, at the end, you just deliver a bottleneck in production. And having this kind of view at the service level with multiple pieces of software deployed is very important. Another part, it's Kiali. Kiali is a famous dashboarding system developed and provided by Red Hat. It's very useful. You have a lot of information, not only about network, but also about logs, inbound and outbound metrics. All the configuration is embedded. So it's an alternative to the Cloud Console provided by the cloud provider, by the way. And the last one, Grafana, which is the famous dashboarding system. You can, and which is really useful in the Istio context, because Istio can configure for you the dashboard automatically. So if you deploy a new service, you will have a specific dashboard deployed at the same time. So really useful to follow all your services in production with it. Everything is free because it's using some open source software, but be careful, it's free, but all this tooling are using some data, and this data is really helpful when you have a problem in production. So if you want to debug something in production, you need to have access to this data, and we know how hard it is to manage data in production with stateful set and data like that. It's really a pain. So if you need it, okay, but you need to take care of it, because this data need to be able to help you when a problem arises inside your cluster. So now we'll see how to connect things inside Istio. So you should be, you already know it's about YAML at Kubernetes level. And with Istio, it's again about YAML, but more YAML. One good side here is it's not you don't need to replace your favorite YAML deployments, stateful set services. You don't need to replace them. It's just an addition over the Kubernetes one. So if you want to live with or without Istio, you just need to add and remove some files. It's not just some kind of replacement from one by the other. So we'll introduce some kind here. The first one is the virtual service. If you think about it twice, we are just talking about some proxy configuration in this context. So here, the virtual service is the definition of how a request is routed when the request goes through the proxy to the outside world. So it's just about that. And the destination rule, it's the opposite. When a proxy receives a request, how it will be routed inside the subset of pod behind the proxy. And the last one is the gateway. The gateway is an alternative to the ingress. It can be used as an ingress class, by the way, but it's one way to configure. It's just a proxy deployed alone, not with another application alongside. It's deployed alone in your proxy to expose your proxy to internet in some cases. And you have the ingress and the egress to provide some kind of outside traffic to your cluster. So every application won't be able to communicate directly to the outside world. It's done at the egress traffic level. And if we take a look at the link between the virtual service and the destination rule, the link is clear here. The host on the left is used on the right, and the subset too on both cases. And now we'll try to control everything. And to control whatever number of microservices you have in production, you've already seen almost every YAML you can configure to do wonderful thing with Istio, because everything is hidden in virtual service and destination rule. In this context, I've removed the match keyword. If I remove that, it's just match equal empty object, and everything is matched in this context. So everything on the left is routed to the right. But I can add some wonderful and good element on this match keyword to do what I call the go-to production flow. So for me, in Kubernetes, when I want to deploy something, the new version, imagine I have my application in V1 in production, and I want to deploy V2. The V2 application in Kubernetes without Istio, I just need to change the image at the deployment level, and then my application in 1, 2, or 3 minutes, depending on the startup time of your application, is deployed in V2. For me, 2 or 3 minutes. It's not the good way to deploy something in production, and to be confident about that. So with Istio, we are able to do that with specific steps. The first one is traffic mirroring. For me, traffic mirroring is also called testing in production, but not the bad way to test in production. We want to test in production because in production we have the request, the real one, but we don't want to disturb every customers inside our production. So we want to exploit this by mirroring the traffic from the V1 to the V2, but in a fire and forget mode. So if I go to my demo here, I've just launched some curl inside both pane here. The first, you see, I will deliver my middleware in V1 currently, and I will deliver the V2 one. And to do that, I will activate first the mirroring system. So I can apply this YAML. So you see it here. I just add mirror version 2. And if I continue, I have the same thing with some label to target some pod, version 2 in the destination rule. And as soon as I apply this, you will see there is some delay in the UI, but you start to see some bubbles coming from V1 here, the front V1, to V2. So I've done some mirroring between V1 and V2. And you can see it in action here. Every call are made again to V1. So every end user, they can't even think about this mirroring thing done in the background for you to test your application. It's one step to deliver our application. So it's my backup slide, just in case. And during this delivery, I'm able to monitor my application, and I'm able to monitor it every time. But during that, I can follow the CPU consumption, RAM consumption, endpoints are working or not. Maybe they are slower than previously, and they maybe are crashing with 500 errors. So I can follow that, and at the end, I'm able to see if my application is able to go in production. But again, step by step, I won't deliver it fully again. I will do some canary deployment then. Canary deployment is the way to provide your application to some customers with specific knowledge about your system. So in this context, I will switch back to the demo again. In this context, I will just, here you can see V1. This pane is a bit different. I'm receiving traffic from V1, but I've just added one header. So you will see in action, we'll read first the YAML. We'll add a specific match here. If the headers equal version equals beta, we'll go to V2, but the other will stay on V1. So if I apply that here, you see instantly it's done and we are reaching V2 from this pane. But the first one, without any knowledge of this specific header thing, still reaching V1. So very simple with just few YAML keyword to deploy our application from V1 to V2 for some specific end users. And you can do that at the whole system level. So here, for me, it's middleware, but you can do that for one endpoint, one verb, one specific headers, like done in the demo. You can choose whatever solution you want. You can do that, and you can discriminate your request and do this kind of thing just for some part of your traffic. And at the end, you can also do some strange thing. I've done that in the past. I know it's not a good idea, but I had some customer why he wasn't able to deploy in production the specific header thing. So at the end, we use some headers injected by the cloud load balancer to use this X forwarded for header with the IP of our customer. It was a good solution. It's not meant to be used like that, but still it's a solution in this context. And then, because I've tested my application with mirroring, I've tested it with canary deployment, I can test it now with traffic splitting, because I don't want to deploy everything in 2 minutes. I want to test with specific steps my application. And here, again, I will switch to my demo. We'll be able to do some fine-grained delivery to only provide V2 to 1% or 10% in this context. Yes, it's 10%. 10% on V2, but the other 90% on V1. So if I found something, in my system because I found a bug or something it's not working as expected, I can roll back my users. So it's very useful to do this kind of routing thing just by adding weight 10% and weight 90%. And at the end, here you start to see more and more V2 coming because I switched to 50%. And then again, I just changing the value here. And then the last step is deploying 100% to V2 and 0% to V1. Here, what you in Kiali is a bit delayed at the UI level because it's the metrics from the last minute. So you start to see the bubbles here are decreasing, but still not like here full on V2. But at the end, in 1 minute, everything will be in V2 and nothing to V1. Here, it's done for the demo. So backup slide again. So again, you need to follow your application because thanks to that, you're able to get a lot of information and you're able to see it in action, CPU, RAMs, and whatever metrics you need to follow to see if your application is okay. And thanks to mirroring, canary, splitting, and at the end, you are able to provide some kind of release without any downtime. Without any downtime because you didn't shut down the application. V1 and V2 were up all the time from the beginning to the end. So nothing is lost in this context. So another step, if you're able to do this resiliency thing during delivery, we can do that all the time. And for me, it's very important to prevent any fault in the cluster. With this kind of YAML at the virtual service level here, we can implement some kind of retry at infrastructure level. So stop doing that in your application, at the end, it's the job of the proxy to do the retry for you. And doing some retry at application level, it's really messy to test, to implement. At the end, it's something which should be done at infrastructure level, not at production level. And yeah, for me, it's useless here. So just by doing that, your application is calling the remote system, in fact, calling the proxy. The proxy is doing the first call, the second call is failing too, and at the end, the third one is the right one, and the response is sent back to the application. From the application point of view, is just some latency. The application just triggered one call, nothing more. Another pattern is the rate limiting, because in some cases you can deliver an application which is not able to receive too much load at the same time. So first, don't choose this kind of data in production. It's too much, it's just for the example. But the idea here is just if one application is calling another one and a second application is calling the same one during the same time span, the second one will fail because the first one is not able to get two requests in the same time. So very helpful if you want to order things and be sure your application won't be overwhelmed in production because you have deployed a legacy one with some cloud native one, and the cloud native is way better in this context. So very helpful, very useful. And the last one in this part, it's about pool ejection. Pool ejection can be seen as the readiness probe, but on steroids, because readiness probe is only at one endpoint level. Here, it's at the whole microservice level. And again, don't use this kind of value in production. To demonstrate it, it's if your application is calling another one and this other one is failing for whatever reason, the Istio will take out of the pool this pod, but without shutting down or restart of it. It's just ejected from the pool at the network list level, and then everything can go well outside without this pod. And this pod is maybe in failure because some garbage collector is happening in the background, or maybe a job background job has been launched in these instances. So if you try to shut it down and start it again, at the end it will have to restart this task, and it will be maybe longer than just waiting for this application to be in a stable state than doing some kind of restart. So after 5 minutes in this example, the application will be back in the pool and available for everyone. So this is the pool ejection. And thanks to that, so retry, rate limiting, pool ejection, you can achieve global resiliency in your system provided by the infrastructure, and nothing has to be done at your application level. So you remove code from your application and you rely on something in the infrastructure. And because we can do that to provide something very cool at infrastructure level, we can also use it to do some chaos engineering thing. And we can do so some kind of fault injection. Because with this kind of code, I wrote that a lot lately. I'm calling the cache, and if the cache is not here or the cache is done, I'm calling the database. But still, to test it in unit testing, it's very simple to test it. But still, in production, it's really hard because the cache, if you kill a node cache at the end, it will start so fast, you won't be able to get 400 errors at cache level. And thanks to Istio, you are able to inject some kind of error in this context. 10% of the time, you will receive at your application level 400 errors. Or you can increase the delay of response between systems. So you can inject errors before your cloud provider or your system will crash for a real reason. Here, you are able to test it on some specific case. So if you see a delay in your database, you are able to test it before something goes wrong in production. Very, very useful. Another part, it's about security. And security, in most cases, it's not because you are working inside Kubernetes, inside the network of Kubernetes. You need to think everything is safe inside. You need to secure your communication, even between application of the same technology is hard to do with MTLS, but easier to do than using multi-MTLS with JS, Go, and Java in the same cluster. I don't want to read the curl documentation to do some curl call with MTLS. At the end, it's too much. And thanks to Istio, again, because we have access to and we have control over the network, we can implement this kind of mutual tele things just by using two YAML. The first one is the definition to enable this MTLS thing, and the second one to define which services, and in this context, it's all the services in the specific namespace will use MTLS. And Istio and the Citadel part will deploy some certificate in every proxies, and proxies will use that to communicate to each other. And the Citadel is not only able to provide this, but it will do the rotation, because when you do some mutual teleasing, you have to change your certificate. It's very important. So here it's managed for you by the infrastructure again. At the application level, it's just some HTTP call. Another part, it's about authentication and authorization. If you are using, for example, GWT in production with maybe Keycloak or Google, whatever solution you want, you can just declare some issuer of this GWT token, and you can define who is, for example, a customer. It's an authorization policy here. If the customer has the claim group set to customer, at the end is allowed to access application with label app UI with the verb get on /orders and whatever at the end. And thanks to that, the proxy will receive the GWT information, decode it, check the customer is with the group claim, and if it's okay, the request is sent to the application. If it's not, the proxy will reject the request, and you don't have to implement anything at application level for coarse-grain limitation. It's only at endpoint level, but still it's very useful to do that at proxy level and not in the app. So with Istio, you have access to every kind of thing like observability, connection, control, and security to provide for you as a developer or as an operator a better infrastructure for your application and for your workload. And you can go a bit beyond that, because the proxy from the beginning, it's Envoy, a very famous proxy developed in C++, and we can load some kind of Lua code or Lua code inside YAML. It's a bit ugly, but yeah, still. We can deploy this kind of thing to do some modification at request level. So here, imagine our previous case. I want to extract the group claim and inject this value to the application in a specific header. So at the end, the application doesn't have to know the authentication system. It's maybe by basic oath, it's maybe by GWT or Biscuit or Macaron or whatever solution provided to do the authentication. It's done outside of the application, and the application just need to check this header, and you can do this kind of transformation directly from the proxy. But Lua and YAML is ugly again, so we can do that with WebAssembly. So C++, Rust, Go, Kotlin, whatever solution able to be compiled in WebAssembly is compatible, and you can even deploy your application and modification of the proxy to the WebAssembly hub, a kind of hub where you can find this kind of module on the shelf to be uploaded inside your system. So again, very useful from an operator point of view. Another part is the mesh expansion. I talked about VMs before, and you, in some kind of installation, you don't want to deploy your, for example, Postgres inside your cluster, because managing data inside the cluster is hard. So I want to keep my workload outside the cluster. And yeah, it's a good solution in this context. And you can still use Istio here, because you can install the proxy. For example, here with apt-get install Istio proxy. It will be installed inside your virtual machine. You need to manage it and upgrade it. It won't be done automatically by Istio, by the way, but at the end, you provide the information to this proxy to communicate to your cluster with Istio, and then it will be seen by Istio like another pod, like another workload in your cluster, and you will be able to do everything I've demonstrated with traffic splitting, multiple version in production, whatever. You can do that just with virtual machine. And there is a lot of feature in Istio. I don't have time to introduce you everything. It's really a powerful tool. So you can check the official documentation. There are a lot of example, and it's not just example about a feature, it's example on how to use it in production. So very interesting. So how do we start with Istio? In Kubernetes, we used to use something like istio-ctl, so a specific command line. Istio-ctl is the official command line for Istio, and istio-ctl install. It will be deployed with. There is many parameters during the installation, so Istio provides you many profiles to do specific thing, production, demo. I use the demo one. Don't use them. Don't use it in production, by the way. It's just for demo, obviously. And thanks to that, you're able to do your installation with. It's really simple to do that. And from my point of view, a simpler way again to do that, it's to use Google Kubernetes Engine. I'm working with that, but with Istio, during the cluster creation, I have a checkbox to enable Istio, and my installation is done with Istio directly in the cluster I want to use. And because of that, it's connected inside the Cloud Console. So every data gathered by the proxy are forwarded to Cloud Monitoring. So I can have everything. I have everything from the cluster directly inside the Cloud Console. And I don't have to care about this data because it's extracted and managed by the cloud provider in this context. This pane is really, really important, seeing distributed trace. And usually I have traces and logs inside the same view, in the same view. Sorry, it's really useful to solve bugs in production without deploying a specific part of the code or increasing log levels. Very, very useful, and I don't need to bring anything from Google Cloud in my code. It's just standard code here. And you can bring all the tools from the cloud monitoring system. You have a new flavor on Google Cloud, it's Onto Service Mesh. You can see it as the previous version, but on steroid again. It's almost Kiali at the UI level. You have all the information, request per second, pods, deployment. You can do all the go-to production flow I've done, but with the UI if you don't like the YAML way of doing. And it's very powerful. But the killing feature from my point of view is this SRE and SRE systems. SRE stands for Site Reliability Engineering, because when you deploy an application, for example, you deploy once a month, between two versions, you have some kind of modification at performance level. I've lost 10 milliseconds, but at the end of the year, you will maybe forget you lost 10%, 10 milliseconds at every releases. Here, you are able to do this comparison over time to see, oh yeah, we've done a lot of improvement, but we lose some performance here, or we consume more CPU than 1 year ago. So we need to do some kind of evolution at this level. And it's very integrated inside the Cloud Console, and you have all the information, and you can define and follow the SRE, Site Reliability Engineering thing directly inside the Cloud Console for you. Very, very good. To finish, Istio is available almost everywhere. I've done my presentation using the open source solution. The open source one is available for everyone. You have the Google Cloud with two flavors, Banzai Cloud, IBM Cloud, and you also have it in OpenShift with its own controller to install everything for you. So in the time I have, it's all I can present about Istio. I hope you enjoy it. And if you have any question, don't hesitate to reach me on Twitter and whatever platform you want. Thank you again.